Next chapter, first order partial differential equation. Second chapter, first order partial differential equation. So the definition of partial differential equation. A partial differential equation is a relation between dependent variables and partial derivatives of dependent variables with respect to more than one independent variables. More than one independent variables. That is, the partial differential equation contains more than one independent variables. That is the relation between dependent variable and independent variable and partial derivatives of dependent variable with respect to more than one independent variable. The general form of the differential equation, partial differential equation is this: f is the function of x, y, z, and theta x, theta y, theta z. That is the uh, derivative with respect to x, derivative with respect to y, with respect to z. Okay, so this contains more than one independent variables. Order of a partial differential equation. It is the order of the highest partial derivative. That is, order of the partial differential equation is what? Is the order of the highest partial derivative. If z is equal to f of xy, z is a dependent variable and x and y are independent variables. Z is the function of x and y. Then we denote dA by z by dA by x by small p, and dA by z by dA by y is equal to small q. So remember this notation for the chapter number 2, that small p means dA by z by dA by x and small q means dA by z by dA by y. Then the equation f x y z p q is equal to 0 is the first order partial differential equation. That is, this is the relation. This is the function. F is the function between x, y, z. These are the independent variables, and p and q. So what is p? Small p, dA by z by dA by x. Small q is dA by z by dA by y. So this is the general form of the partial differential equation of first order. F x y z p q is equal to, what is p? P is dA by z by dA by x, and q is dA by z by dA by y. So z is the dependent variable and x and y are the independent variable. Z is the dependent variable and x and y are the independent variables. So this is the general form of the first order partial differential equation. F x y z p q is equal to 0. For example, the example of first order partial differential equation is what? X plus 2z dA by z by dA by x plus 4zx minus y dA by z by dA by y is equal to 2x square plus y. So this is the one of the example of first order partial differential equation. So z is the dependent variable and x is the independent. X and y are the independent variables. So in the partial differential equation, the independent variables are more than one. So the definition of a partial differential equation is what? Is the relation between dependent and independent variables and partial derivatives of dependent variable with respect to more than one variable, more than one independent variable. So this is the general form of the first order partial differential equation. So this is the example of one of the example of partial differential equation. That is, in the partial differential equation, the derivative of dependent variables are with respect to more than one independent variables. Here dA by z by dA by x and dA by z by dA by y are small p and small q. So eliminate f from the equation. Z is equal to fr, r is equal to x square plus y square raised to half, or root x square plus y square. Raised to half means root x square plus y square is the z from the partial differential equation. This is the partial differential equation. So we have to eliminate f from this partial differential equation, from this equation. Z is equal to fr. So z is equal to fr, And r is what? R is root x square plus y square raised to half, means r square is what? X square plus y square. So differentiate with respect to x, dA by z by dA by x is what? F dash r. So differentiate this z is equal to fr with respect to x. So we have dA by z by dA by x is f dash r, dA by r bar by dA by x, because this function fr is the function of r. So, and we have to differentiate with respect to x. So multiply by dA by r by dA by x, f dash r, dA by r by dA by x, and that is f dash r, dA by r by dA by x. This is the r. So its derivative is with respect to x is what? 1/2 x square plus y square raised to 1/2 minus 1 is minus 1/2 into derivative of x square plus y square is 2x. With respect to x, derivative of x square is 2x, derivative of y square is 0. That is, we have 2 to get cancelled. X f dash r divided by x square plus y square raised to half. That is x by r. X square plus y square raised to half means r. So x by r f dash r. Right here r f dash r. This is 1. Similarly, if we find dA by z by dA by y in the same method, we have it is y by r. In the place of x, we have y by r f dash r. This is equation number 2. Then multiplying equation 2 by x and 1 by y and subtracting, we have what we have? Y dA by z by dA by x minus x dA by z by dA by y is equal to, then this value is what? X y by r f dash r, and minus x y by r f dash r becomes 0. So multiplying equation 2 by x and 1 by y and subtracting, we have this y dA by z by dA by x minus x dA by z by dA by y is equal to 0. And this is in another form, yp. P is what? Small p is what? dA by z by dA by x, and small q is dA by z by dA by. So yp minus xq is equal to 0. And this is the first order partial differential equation after eliminating f. So this is the, actually the topic is formation of differential equation. That is, solution is given. Actually, this is the solution, and this is the required partial differential equation. So yp minus xq is equal to 0. A y dA by z by dA by x minus x dA by z by dA by is equal to 0. This is the first order partial differential equation. That is, this y z is equal to fr, that where r is x square plus y square raised to 1/2 is the solution of this differential equation. So we are given solution and we have to form the differential equation in this first topic. It's called formation of differential equation. Eliminate, next problem, eliminate f and from the partial differential equation, from the partial differential, and form the partial differential equation from the equation f of uv is equal to 0. Eliminate this capital F from the, and form the partial differential equation from the equation f of uv is equal to 0. Same question. Here is the eliminate f from this equation and form the partial differential equation. That is, we have to obtain the partial differential equation whose solution is f of uv is equal to 0. We have to obtain the partial differential equation whose solution is f of uv is equal to 0. This is the solution. Solution is given. So the first topic is formation of differential equation. So in the first topic, the solution of the differential equation is given, and we have to form the partial differential equation. So we have to form the partial differential equation whose solution is f of uv is equal to 0. So consider f of uv is equal to 0. We have to eliminate this f from this differential from this equation. So consider f of uv is equal to 0, where u and v are the functions of x, y, z, and z is the function of x and y. That is, x and y are independent variables, and z is the dependent variable, and u and v are the functions of x, y, z. So differentiate with respect to x we get. So what is the procedure to obtain the differential equation, partial differential equation? That is, differentiate with respect to x, differentiate with respect to y, and we have the equation number 1 and equation number 2, and from equation number 1 and 2, we have to obtain the required partial differential equation. So how we can obtain from equation 1 and 2? That is subtracting either this, subtract these two, or add these two, multiply these two, or multiply to equation number 1 by some quantity, some multiply equation 2 by some quantity like this. That is multiply equation 2 by 1, 2 by x, 1 by y, and subtracting or adding, multiplying, we have the required differential, partial differential equation. So in order to obtain the partial differential equation from the solution, we have to differentiate with respect to x and y, and that are the equation number 1 and 2, and then from that two equations we have to obtain the required partial differential equation. So first, differentiate with respect to x, this f of u is equal to 0. So we have dou f by dou u, then the derivative of the function f with respect to x. So dou f by dou u into dou u by dou x, dou x by dou x, dou u by dou z, dou z by dou x. By using chain rule, dou f by dou u by dou x. First is what? Derivative f is function of u and v. So its derivative is what? Dou f by dou u by dou x plus dou f by dou v by dou x. And what is dou f by dou u? What is dou u by dou x? U is the function of x, y, z. And so its derivative with respect to x is what? The derivative of u with respect to x is what? Dou u by dou x by dou x. Because u is the function of x, y, z. Then dou u by dou y by dou x is 0. The derivative of x with respect to y is 0, and derivative of y with respect to x is 0, because x and y are independent variables. X and y are independent variables. So derivative of x with respect to y is 0, and derivative of y with respect to x is 0. But z is the function of x and y. So we have the derivative of u with respect to x is what? Dou u by dou x by dou y. Then dou u by dou y by dou x is 0. And then next term is dou u by dou z by dou x. Okay. So by using chain rule, the derivative of f of uv is what? Dou f by dou u by dou x. Dou u by dou x is what? Dou u by dou x by dou x, dou u by dou y by dou y, dou u by dou z by dou x. Okay. But dou u by dou y by dou x is 0. That's why the middle term is 0. And dou x by dou x is 1. Similarly, dou f by dou v by dou x is what? Dou v by dou x by dou x plus dou v by dou y. Dou y by dou x is again 0. And dou v by dou z by dou x. Okay. Is equal to 0. Y is independent function, independent variable, and so dou y by dou x is 0. Also dou x by dou y is 0. Then we have to differentiate this equation f of uv is equal to 0 with respect to y. So dou f by dou u by dou y by dou y is 1. So then dou u by dou, actually first term is what? Dou u by dou x by dou y is 0. Then dou u by dou y by dou y is 1. Dou u by dou z by dou y. Plus dou f by dou v. Similarly, the dou v by dou y by dou y is 1. Dou v by dou z by dou y is equal to 0. So this is the derivative of this function f of uv is equal to 0 with respect to x and with respect to y by using chain rule. Suppose these are the equation number 3 and 4. The given equation f of u is equal to 0 is the equation number 1. Then multiplying equation 1 by this bracket dou v by dou y plus dou v by dou z by dou y. Multiplying equation 1 by this term dou v by dou y, dou v by dou z by dou y. And equation 4 by equation 1. Suppose this is the equation 1. This is 1 and this is 2. So 1 by this, and 2 by equation 2 by this dou v by dou x plus dou v by dou z by dou x, and subtracting. That is, we have this term as equal to 0. this term become 0. Okay, so we have w by w, then this bracket w by wx plus w by wz wz by wx into this bracket w by wy plus w by wz wz by wy minus this term w by w by w w by wy plus w by wz wz by wy into this w by wx plus w by wz wz by wx is equal to 0, and this term becomes 0. This term minus this term becomes 0 after multiplying these two. Then next step is what? W by w means f of u, f suffix u. W by wx means u suffix x. W by wz means uz, and wz by wx means small p. So w by wy, w by wz, substitute in another notation. Wz by wy is small q. Similarly, w by w is f suffix u. Then this is uy, uz. Wz by wy is q, vx, vz, and wz by wx is p is equal to 0. Then multiplication of these two brackets. Take f of u as common and cancel it or shift to RHS, so we have 0. Then the multiplication of these two, so dividing by f of u throughout, we have this equation. Then after multiplication of these two bracket, we have these 4 terms. After multiplication of these two bracket, we have these 4 terms. Negative sign is there, so write in bracket multiplication of these two brackets. Then effect of negative sign on these 4 terms, we have this step. And then collect the coefficient of small p. So what are that? Small p, u, h, z, vy. Small p, u, z, vy, this term. Minus uy, vz, small p, uy, vz. Vy, uz, this term. Vy, uz, vy, uz, small p. Ux, vz, p and ux, vz, p